A couple of recent news items about Intel and processors generally illustrate the potential business implications of technology decisions. Behind them both is how a simple truism that applies to many things in life applies specifically to CPU design. I discussed one of the technology decisions in my most recent video, that is the elimination of multi-threading from the next generation P-core Xeon. Intel CEO Lip-Bu Tan, during the company's most recent earnings call, described this as a mistake. Since then, I've posted on xpu.pub an article about simultaneous multithreading, SMT, in general. And here are a few key points. First, SMT enables one CPU to appear as two. Thus, instructions from two different threads or programs can be in flight on the CPU at the same time. This can raise performance because while one thread, for example, is waiting for data coming in from memory, the other thread can use CPU resources. Even if a thread is installed but only uses a fraction of available resources, which is typical, the other thread can use other resources. The throughput increase from running two threads at a time varies and could even be non-existent, but a 15% to 30% increase is typical. The added logic to do this increases CPU area by maybe 5% to 10%. A 30% or 1.3x total increase, however, means that each thread is running at 0.65x the speed it would run if it had the whole CPU to itself. So let's dig into this last point. I used the term P-core Xeon before. Intel has two CPU families. The P-core family is designed to maximize performance, P for performance. The E-core family is designed to be more efficient in terms of manufacturing cost and power, sacrificing performance to achieve these goals. Today, we'll focus on the cost aspect, which comes down to the physical size of the CPU. Other companies have similar distinctions. It was ARM that popularized the two-tier approach, which it called big little, underscoring the size-based motivation behind having two different CPU families. The company actually offers many different CPUs, and its smartphone licensees have built chips with three different CPUs varying in size and performance. And AMD has its regular and its compact CPUs. For today, let's use Intel's nomenclature. P-core for the fastest CPUs and E-core for the lower performing but smaller designs. Here's where the general truism that applies to life comes in. Whatever you do, you seek out the easiest gains first. In CPU terms, every turn of the crank to raise performance costs more and more. Those last increments take a lot more die area than the first speedups implemented. We can run the process in reverse, however. You can get big cost savings by dialing back performance. Performance varies based on whatever program you're using, but you can assume an E-core has about half the peak throughput of a P-core in single thread mode. However, you can fit not two E-cores in the footprint of a single P-core, but three or four. So that's a good deal. You can replace one P-core with three E-cores to get more total throughput for the same cost. This compares favorably with two-way multi-threading, which could boost total throughput by 30% at a slight area increase. This is one reason why some companies, notably ARM, haven't widely implemented SMT. If you're willing to accept a decrease in single thread performance, you'd be better off using more cheaper cores. The problem is that the trade-off is made by the CPU designer if you go that route. A key advantage of SMT is that it can be enabled or disabled by users depending on their workload. An SMT-capable CPU has elasticity. The customer can stretch it one way to get more single-thread performance or stretch it the other way to get more total throughput. So let's turn to the other news item. A few weeks ago, reports surfaced that 2028 generation Titan Lake PC processors from Intel would have only E-cores. Lots of them. I believe these reports are true, and this will be a bigger mistake than simply eliminating SMT from the P-core CPUs in Xeon. In January, XPU.pub had reported essentially the same thing based on an inadvertent public disclosure. The problem is that it's hard to break software into pieces running in parallel. 9 women can't make a baby in 1 month. Moreover, there's little incentive to divide software into ever more cores. The biggest performance-sensitive PC applications are games. Games, however, also target Xbox and PlayStation consoles, and these systems may have about 12 P-cores in the next generation, each capable of running 2 threads, providing developers 24 threads in total. It's unlikely that a game company would want to optimize its code for both the 24-thread game consoles and this 100-core PC, and it might not even be practical to do this anyway. Thus, why have so many E-cores? And with no P-cores available, performance is going to suffer. So how will this play out for Intel? For PC Core Xeons, Intel really needed a competitive product to staunch its share loss. It's clear that Lip-Bu is worried about that next Xeon, which is named Diamond Rapids. I doubt every customer will reject it, but the company really can't afford even some customers to have a reason not to choose it. Customers seeking out an SMT-capable x86 processor will simply buy from AMD. As for the all-E-core PC processor, Intel has a commanding share of the PC processor market. Hobbyists and others sensitive to performance will avoid systems based on an all-E-core chip. Although most PC buyers aren't performance conscious, OEMs might not want to risk users noticing app responsive being worse with the new chip than with the prior generation or a competing chip. And having stuck with Intel during the past several years as its operations have foundered, OEMs have little goodwill toward the company. I expect them to be much less forgiving of a conscious decision to make a product unaligned with market needs than they have been in the past dealing with the company's troubles. Intel's steady share loss that it has experienced in server processors will repeat in the PC processor business. For more information, see xpu.pub. If you found this video interesting, please tell 4 friends. Question or comments, put them below. Until next time, be well.
It's all about the pendients, baby.